Okay, so here's a wild thought. How could an AI, something we build to eat data, actually get smarter by throwing information away? It sounds completely backwards, right? But believe it or not, this is one of the biggest secrets to making AI work. Let's get into it.
To get our heads around this, let's start with something super simple. You ever clean out your school bag? You get rid of all the junk you don't really need anymore? At the start of the semester, it's probably overflowing with everything. But pretty soon, you start tossing stuff. Old assignments, that textbook for a class you had yesterday, and there's a good reason we do that.
For one, it just gets lighter. That's the first one you notice, right? And then it's way easier to carry around. No more feeling like you're lugging a ton of bricks. And maybe the best part, it's way more organized. You can actually find what you're looking for without having to dig through a mountain of clutter. It's all about making things efficient. And guess what? That's exactly the same game AI is playing with data. So let's take that backpack idea and apply it to AI. Because an AI model is basically doing the same thing, just on a mind-bogglingly huge digital scale.
All right, the fancy technical name for this whole process is dimensionality reduction. It sounds complicated, but the idea is actually super simple. You're just cutting down the number of features, the number of details in your data. But, and this is the crucial part, you do it while making sure you keep all the most important stuff. It's not about deleting data randomly. It's about cutting out the noise so you can hear the signal.
So when I say dimension, what am I even talking about? Well, in the world of AI, a dimension is really just a feature. It's a single piece of information. For example, if you wanted to describe a student, you might use features like their height, their weight, their age, how many hours they study, their attendance record, and their homework score. See, each one of those things is a feature, a dimension. So for that student, we're looking at a 6-dimensional data set. Simple as that.
Okay, 6 dimensions, we can wrap our heads around that. But some of the AI models out there are juggling data sets with hundreds, thousands, or even millions of dimensions. Just try to picture that. It's like that school bag analogy, but instead of a few extra books, you're trying to find one specific pen in a bag filled with a million other things. It's not just hard, it's pretty much impossible. So that brings us to the big question. Why is less actually more for AI? What's the real payoff for all this digital tidying up? And this really breaks it down perfectly. When you have way too many features, you run into huge problems. Your AI takes forever to train. It eats up a ton of memory. And you risk it getting confused by all the noise. That's called overfitting. But when you narrow it down to fewer, more meaningful features, suddenly everything gets faster. Performance goes up. And you can even visualize the data and see what's going on. Here's a great way to think about it. Imagine you have 20 different test scores for a student. Instead of feeding all 20 of those into an AI, what if you just combined them into one single overall performance score? Boom. You've just gone from 20 dimensions down to 1, but you've kept the most important information.
I absolutely love this next analogy. It's like taking a 3D object, say a sculpture, and just drawing its shadow on a piece of paper. The shadow is 2D, right? You've lost a dimension. But you've kept the most important part, the main shape, the outline. You simplified it, but you didn't lose the essence of what it is. Okay, so how do data scientists and engineers actually do this? Let's take a peek inside their toolkit. We're not going to get bogged down in the crazy math, just the big, clever ideas behind how they create these data shadows.
All right, first up is the most common method you'll hear about. It's called PCA, which stands for Principal Component Analysis. The best way to think about it is like this. Imagine you're holding a really weirdly shaped object. You'd probably turn it around in your hands to find the best angle to look at it, right? The angle that tells you the most about its shape? Well, that's what PCA does with data. It finds the most important directions or views to get the most meaningful picture. Next in the toolkit is something called TSNE. I like to think of this one as the data artist. Its main job is visualization. It takes all that impossibly complex, high-dimensional data and squishes it down onto a 2D or 3D plot that we humans can actually look at. It's amazing for spotting patterns and natural groups or clusters that you'd never see otherwise.
And then you have the really cool deep learning approach, autoencoders. This is seriously clever stuff. So you have a neural network, and its first job is to squish the data down, compress it into a really simple form. That's step 1. Step 2? It then tries to recreate the original data using only that compressed version. And here's the magic. If it can rebuild it accurately, that means the simple, compressed version must have captured all the really important information.
And you better believe this field is moving at lightning speed. Deep learning methods, like those autoencoders, are getting more and more automated. We're already seeing new algorithms designed to chew through massive data sets faster than ever. And looking ahead, the real cutting edge is all about combining these techniques, smartly picking the best features first, and then simplifying them for absolute peak performance. Okay, I know this can all sound a little abstract and out there, but the truth is you are using the results of this stuff every single day. So let's bring it back home and look at where this data simplification is hiding in plain sight. Think about this. Every time your phone saves a picture, it compresses the image file. That's dimensionality reduction. It throws away info you can't really see to save storage space. Or how about when you're shopping online and it gives you those spooky good recommendations? That's because it's taken your entire complex shopping history and boiled it down to a few key taste dimensions. And Google Search, to find what you want that fast, it has to simplify the entire internet. It's everywhere.
So, we've covered a lot of ground. What's the big takeaway here? If you remember just one thing from all of this, what should it be?
Here it is, your one-line memory trick. Dimensionality reduction is just about simplifying without losing the meaning. That's it. It's the art of finding the important stuff, the signal buried in all the noise.
And that kind of leaves us with one last thing to think about, doesn't it? We've just seen how AI literally gets smarter by cutting out the noise and focusing only on what matters. So it makes you wonder, what noise could we simplify or remove in our own lives to help us see things a little more clearly?